making them, the processing part. Then we will slowly move towards including 3D printing into it, and then we will take the further special applications. More or less we are going to focus more on the polymer side, because Professor Dumitru as well as me, we are more into, or we are more comfortable with working in the polymers. So that would be our major point of interest for this discussion. So I will initiate my discussion on processing of polymer matrix composites, and these are some of the contents. I will not go into too much detail of the classifications, because probably that has been in a way discussed by Professor in the earlier session. So we know that when we combine different types of reinforcements into matrix, our intention is to generate a part which we call composite. And the beauty is that these two or maybe more entities, they maintain their distinct existence into it. But when they combine together, they come up with a new flavor, they come up with a new property, they come up with a new application. So unlike alloys, this becomes a better option, because you are able to keep them distinctly different and still combine their capabilities together. So what are those reinforcements? These reinforcements can be some form of particles, usually metal particles, but of late there are possibilities of putting up polymer particles also now. So either we fill small particles or short fibers, chopped fibers. Now we even have fibers also into particle size now. So we fill them, or we reinforce the matrix with the continuous fibers. So as far as these three distinct things are concerned, the particles or the short fibers or the long continuous fibers, they have different sort of applications. So those which are having better applications, higher applications into structural components, so there we need to use the continuous fibers. So those composites with continuous fibers, they are more into structural parts, so they are more into functional applications. When we use continuous fibers, but maybe they are not aligned properly, so you mix them the way you want. Say for example, that happens more with the natural fibers. So we haven't processed them, so probably we are not able to put them into proper alignment. So non-aligned but continuous fibers, they have lesser capabilities, they have lesser strength, they have lesser properties as compared to the structural parts. Finally, there are non-structural parts which have either particles or chopped fibers. So in such a scenario, they are more into prototyping, or they are more into the applications where the structure does not play any major role. Probably we do not require them to perform specific functions. They only remain part of one or the other application, but they themselves, they do not take part into activity. So considering this, I wish to focus on these three things today, right now. One is polymer matrix, where the fibers are reinforced and these fibers are largely continuous fibers. I may come up with some discussion wherein some applications wherein there are chopped fibers into the application, but I'll restrict myself more on the discussion on the continuous fibers. The reason being, we have worked on it. 2 or 3 MTech students and 1 PhD student have worked on it. So for that discussion, I am more comfortable. So I'll come up with certain applications, certain specific processing techniques, but my focus would be on the one which we have used. So, when we talk about this composites, we talk about the way in which these fibers are arranged. So, we may place them say unidirectional, the fibers are unidirectional or they are bidirectional. When the fibers are bidirectional, mostly fabric is used. Okay, fabric is prepared from our clothes are also fabrics, right? They are also natural fibers. So, those fibers are arranged in a specific fashion in a fabric. So, when we talk about bidirectional applications, we mostly use fabrics. Unidirectional are those fibers which are in a single direction, but they are tied with each other. So, they try to remain. Often we might have seen that there are many in our traditional applications. We have those curtains. Those curtains are the way in which we arrange. I don't call it a composite, but those fibers are those threads are placed that when they are tied together on both the ends. So, that is how even in certain applications where natural fibers are used, they are largely unidirectional. Then there are multidirectional also. Multidirectional means you mix them. In case if we are working on it, we try to put them at perpendicular to each other and then at certain angle with each other. So, that is how it takes a multi-directional approach. And finally, there is something which often we our life also goes that way naturally, that is the random arrangements of the fibers. So far, every time the beauty of random arrangement is every time you get some new result. And even if you say that okay, those 5 researchers have concluded something, I am concluding something else, none of those 5 will contradict you, because they also have doubt. When they referred someone, they had reported something else. So, when fibers are random, in a way that is easier for us to claim some results, because every time the randomization may be different and that may result into some way. And often you see those papers wherein especially on banana fibers, if you see papers on cotton fibers, even I came across one paper where they have used sugarcane fibers. So, there blah blah blah, they claim anything and still you cannot say that no, you are wrong, you cannot say that. So, usually the focus is more on unidirectional or bidirectional study. Now, there is a twist into this uni or bidirectional arrangement of the fibers. What we do is we mix different types of threads together. So, either you have fabrics and you keep on changing the fabrics. One layer is one fabric A, then fabric B and fabric C. So, you combine layer wise, you combine those fabrics layer by layer. Or what you do is you create yarns, but with those yarns you make different combinations, maybe in bidirectional. So, often the clothes that we have and multicolor clothes that you see, those are different yarns that are put together in a specific fashion. And then the third one is intra yarn, the combination of different fibers inside one yarn. So, each thread is combined with some other threads at a time. So, there are 3 ways in which different fibers are used together, be it natural, be it man-made, be it combination of them, but that gives rise to altogether a new way of taking up the study of composites, and we call it hybrid composites. So, when I say hybrid composites, I may have worked on natural fibers. When I say hybrid composites, I may have worked on man-made fibers. When I say composites, I may have combined man-made and natural fibers. Again, when I say hybrid, I may have put up in these 3 ways. So, there are n number of possibilities that you can study, and that leads to. So, when we see that hybrid composites, if you search in Google, in Google Scholar, if you search, in last 2 years, 22-23 itself, you will find at least 600 papers on hybrid composites, processing of hybrid composites. I am not talking about ANN and AIML, no, those things are extra. So, this is a huge possibility, and the way we see those natural fibers in different parts of our nation, I believe there is a good scope that we can try to replace the man-made fibers or partially replace them if not fully. So, this is the basic classification of different processing techniques. When we work on thermoset composites or thermoplastic, we may use short fibers or continuous fibers, and that way we may go for different types of strategies. I will not restrict myself to this particular classification right now, because many of these or few of them I just want to go through. So, they may fall into either of the category, but I will not restrict myself to that. Now, why is it important to study this? Why it is required that we go into too much of investigations on processing and characterization of composites? So, there are three interesting graphs which I came across. One of them is this, and I will not go into too much of discussion on this, but there is a one full lecture of 45 minutes by Professor Ram Kumar, IIT Kanpur, wherein he talks only about this graph. In his entire lecture series, there is one lecture of 45 minutes where he talks about this, and I tell you, it was very difficult for me to find this graph online, but I felt that yes, I want to discuss this. Based on this, he has taken the entire subject. The entire subject is based on this particular graph. So, when we consider this classification of structural performance, semi-structural or non-structural performance, and various applications, okay, these are different applications, aerospace. Now, when we talk about aerospace applications, you largely need those parts to be for structural applications, and when you take consumer appliances, they are more into non-structural applications. Now, how many units do we make? The number of units that you make, depending on that and depending on these combinations, there are different processes available. So, in a way, what is happening is, if you say process A, that process A has more of its application in certain combination of tasks. Say, when you want to go for structural applications for aerospace, then you have those two processes. But what is the limitation in this part? You cannot go to number beyond this. Your the number of units that you produce per annum is less. But similarly, if you want to go for same application, you do not have anything over here. There is a huge potential of occupying this space. You take hand layup process. I like this process very much, because when I joined SVNIT as a student, I had a senior who was doing PhD, and you know, we always help our seniors. So, I also helped him for his task, and he was working on this hand layup process. So, that was my first hands-on experience with composites. Since then, many processes we could work on. But if you take this, see, it largely remains restricted to this. The reason for lesser number of units that you make with hand layup or with autoclave or filament winding, the reasons are quite different. Why you make only say 100 parts a year? The reasons which are applicable for this process do not apply for these processes, even though they are at the same level. That goes with either this part or both. So, that is very interesting discussion, and there is always a possibility how we can try to bring this. The hand layup is okay, because a human is required and he himself has to put all time and efforts. So, there may not be too much possibility of taking this on the other side, but there is a possibility that we can slightly shift them. I may not be discussing it, but is there a possibility of creating hybrid of these processes? That is something. Hybrid composites involve hybrid fibers, combination of fibers. But what about combining the processes? That is something which may or which should come up in days to come. Similarly, this is another task which is related to productivity, which deals with productivity. As we increase the number and as we want to increase the fiber volume fraction, I want to go see, that is always a common finding in all the results, that your effect of the reinforcement is always more than the effect of resin, than the matrix. Fibers play more role in the strength than the resins. So, if I am able to increase this fiber volume fraction, probably I am always improving the strength part. But then in that case, with any of these processes, there are set targets. You have to go up to this number with these processes. How to do that? You just want to, there is a possibility that you can increase these units with filament winding. Say from 100 you can go up to thousands of numbers. But there is no possibility for you to increase this fiber volume fraction any further with the understanding that we have today. But there is always a possibility with other process. When you use resin transfer process, there is a possibility that you can increase the number. Not only that, there is a possibility of increasing the fiber volume fraction also. So, any attempt that we do for that, that is going to benefit our industry into that. This is another interesting thing. How does the size of the part affect the cycle time? Comparing that, we have different sets of applications. All these three, if I want to create a hybrid of these three graphs, that is also a Herculean task. Probably it may not work. What I want to focus on is, if I want to make a part with any of these processes, any of the process, a small part like a golf ball, it may take lesser time if I go for this process. But if I want to go for something like wind blade, maybe compression molding will not work. It does not work. Okay. So, it will take more time also, and maybe I will have to go for the other processes. These graphs do not talk about 3D printing. After 3D printing came into picture, everything else is getting vibrant now, because it comes into this field. So, that does not this discussion does not include 3D printing yet. So, many more things change because of that. Maybe we will discuss that in our coming sessions. Probably it would be something that is size of an animal, or maybe size of a truck. That is related to the size, right? I wonder why they did not put up some scale like meter. Okay. Now, I want to focus on certain processes, and those processes I want to talk about specific parts of this entire processing. But more or less in all the processes, any process or any technique that we consider, the steps of process would remain same. I need to decide what type of matrix I want to use. I need to decide what type of reinforcement I want to use, and I should have reasons for selecting a natural fiber or a man-made fiber or a combination of fibers. So, the important thing is the material selection. I select natural fiber or I select man-made fiber, but how I am going to place it in the part that I want to fabricate. So, what way I would be arranging them. So, preparation of reinforcement is also equally crucial. So, do I want them to be at same angle? Do I want them to be aligned at different angles? Different means right angle only, or maybe I want to put one fiber at certain angle with the other. So, those arrangements, multiple fibers, same fiber material, so hybriding them at certain inclination, those things have to be initially decided. Now, when specifically we go for processes where I am not using continuous fibers, where I prefer to use particles or maybe short fibers, then this mixing and dispersion becomes important. There is a possibility that you may use resin A and fiber A to make a part composite A. But in the same resin I can also mix certain particles. In the same resin I can also mix certain short fibers into it, and then create a matrix which is again hybrid, and then I reinforce fibers into it. I mix fibers and place fibers into it. So, that discussion will go into mixing and dispersion, that is very important. Otherwise, what happens is at some, especially when these resins are too viscous, so the dispersion of the particles or the fibers is always a critical task. So, this comes into picture. Now, It is not that you mix powder, some particles into resin or short fibers into resin and you leave it for some particular good day to do the task. Once this is done, immediately you have to fabricate the part. So it is assumed somewhere in between these two, the part is getting initiated for fabrication. However, shaping and forming comes into the discussion when I want to fabricate the part. So do I want it as a flat part? If I want a flat part, that is the easiest thing to do. But what if I want to make a blade? What if I want to make a cone? What if I want to make the bonnet of my car? What if I want to make a tube? What if I want to make any of the irregular shape? So there, the tool that I use, the die that I use, or the mold that I would need to prepare, those processes get into it. So suppose if I want to make a hemisphere, I want to make a hemisphere part, hemispherical part, I want to make a cup. So I will need a pattern, I will need a mold wherein I can place and get this shape. So that becomes a combination of other processes. Maybe I may go for a certain metal forming process or some molding processes. Today I can go for 3D printing process, but I will need something to get into it. So how do I shape the basic shape? How do I carry out this task also gets into it. It is not fabrication of composite, but to make a composite I will need some base, I will need some tool, I will need some pattern or mold. So that thing, that entire process which gets into it will come over here. So once that is done, I place the fabric, maybe continuous fabric, short fabric, whatever I am using, and then I need to allow this resin to solidify. When we first initiated our task sometime in 2016 I suppose. When did you join summer? 15, 16, 17. So sometime in 17 we did that. So when we started doing it, the first thing that happened was, before we could utilize the entire amount of resin, it got cured. We made mistake in adding hardener to it, and we did not know, otherwise I would have put up my photograph into it, then it would have become a very good artistic piece. But yes, that was something that we lost. It remained perfectly transparent, but still it became solid, we could not use it. So there, this solidification becomes a crucial thing when we are working with these resins. So the amount of hardener that you would use. No, that is a matrix. I am talking about matrix at this point of time. So, so once you have this fabric, or once you have the short fibers, or maybe combination of fibers, whatever be it, but you will need to allow them to cure. It depends upon how you have infused them. Have you put them under pressure? Have you just used a brush to place these resins? All of these things will have their effect on the curing part. So depending on the process, the curing and solidification will become a specific task for caution, for study. Okay, curing happened. I got the part. I opened the die maybe, and I removed the part. And then once I do that, I need to do certain post curing. Sometimes it so happens that your experience says that within 24 hours this would be ready, or 12 hours this would be ready. And once you remove it at the 25th hour, you feel that still thoda bhi baki hai. So what you need to do is you need to go for post curing. And so often you take it to maybe in some break you may have some discussion with Arjun. Recently he faced a trouble when he was working with one resin. He thought that let me go for post curing, and instead of 10 minutes, probably 10 minutes, he went for 11 minutes, and all his 54 samples were lost. In just 1 minute they turned brittle. His 3 months of experiments were lost in just 3 minutes. So post curing becomes, instead of UV curing, he thought that let me use the daylight, and daylight brought night into his experimental work. So post curing and heat treatment also gets involved in most of the processes, and then you need to finish the part. Often tomorrow also you will see in one of the setup, one of the side is perfectly finished and the other side you see, you feel that all roughness has come on one side only. So, if I want to use something wherein I need to use both the sides, say for example, this is laminate. If you take laminate only one side, we know that only this side has to be used, the other will definitely get stuck on the ply. So, we are not concerned about it. In fact, we need it to be rough. But then if there is a part which has to be available on both the sides, say something like a glass, then you cannot compromise with one and the other side. So, in such type of applications, we also need to work for finishing that side. So, finishing off one of the side becomes a crucial task. One of the side would be perfectly smooth, will have very good finish, but the other side will give you untimely showers. Finally, quality control everywhere needed, especially in India. We are very much concerned with quality because we take things very casually. So, quality control and testing also becomes an important aspect of this. I will not touch over it because it is not part of processing. I think you will need to replace the cell, I suppose. Okay, so few of the process which I want to discuss at some or the other time, they may have been of interest of research at maybe our place or maybe somewhere in some of our research team, maybe here or somewhere else. So, those processes which I feel that they are of relevance, I have included few process. So, the most elementary process is the hand layup process. Very simple process. As we saw in that graph, we go for lower volume of materials over here, we get lower production, and mostly it is for prototype fabrication. Okay. Only problem is that this is labor intensive. Today you must be knowing, everybody of us knows, because either we are teacher or we are students. Our students do not want to put too much of efforts, and just as we have this generational gap with maybe the gap in the thinking pattern with our papa or maybe with our kids, the same way we have the same generational gap with our students. I always feel that I put up more efforts when I was a student like you. So, this process, I know somebody working on it for 3 continuous years, only this process, and he came up with about 12 SCI papers 12-13 years back. We did not have any importance of SCI paper then, but he came up with 12-13 papers only with hand layup process. The supervisor of that student is going to speak on our last day. He is our current head of the department. You must be knowing Piyush Goyal. So, he put up a lot of effort only on this process. I am witness to it. I got involved into as an assistant for some of those tasks. But in a way, this gives you the best results because you are always sure that this is going to give you result. You will not face situations like what Arjun faced, because the amount of resin that you are using is restricted. You cannot just put a bucket over there. Okay, when you use the brush, everything is limited. So, here the getting of a part is a sure thing. Quality gets compromised or strength gets compromised is a different thing. So, you need to keep on repeating this, and that is why this is called labor intensive process. It is not that you need to put efforts, it is fine to put efforts, but you have to put efforts multiple times to get one part. You get parts, that is a surety, but the quality that you want to have, the strength that you want to have is not a surety. So, that is why this process is known as labor intensive process. So, here what you do is you prepare a simple die. You need to coat it first so that the part can be easily removed. You fill the matrix. Either you can put fabric or you can put chopped fibers, whatever way you want to put. It's just like a how would I say, the sandwich that we make, right? You can put any vegetables you want into it, right? When you go to Subway, they ask you what number of chutney you want, what vegetables you want to put. Everything, if you make a universal set, he'll put everything into it. Same way you can put any fabric. You can put fabric, you can put chopped fibers, anything that you have, even if wastage you have, you can put it. You pour the resin, you get something out of it. So then rolling becomes an important task, because you need to remove those air entrapment from it. Whatever air gets entrapped into it has to be removed, and that happens by proper rolling. Okay. And then finally, after curing, we get the part. So I just discussed, so I'll skip this part. We need to prepare the mold, then we put up the gel coat, then we lay down the fabrics or the fibers into it, and finally once we infuse the resin into it, we get the part. Often we need to trim, because we need to give it a shape, and you will get the final product after proper post processing. This process is most widely used to make boats, and so even I could find this as the best example to put over here. आप ले केवी रीते थशे? So we have a specific shape. We put up the first coat. Here probably it is shown to make hybrid part. So one fabric is laid, then a layer of resin, another fabric, another material comes up, you have another resin, and then you use a roller. So hybrid part can be made, very easy to combine anything that you want. Maybe roller will help you, but yes, it comes with the skill only. So this is how such a part is made. The next video which I am going to play, just try to don't reply, but try to identify what part it makes. I watched the video 3 times, then I could identify what the operator wants to make. Very simple thing. I could not make out. And this is very good music. Yes, everybody got up. So the fabrics are being put up, resin is poured, and rolling is done, so that we remove the air that is entrapped in between. Volume કેવી રીતે ઓછું થાય? Volume કેવી રીતે ઓછું થાય? अब खत्म हो गया, चले गया. This guy is trying to make a chair, but I took 3-4 rewinds to make it. So Chris did a very good task. I know one guy, Siddharth, in Surat. He does not have a startup, but what he is doing is, see, there are people who like to modify their vehicles. So we often see people replacing, changing parts or modifying it in cars. But this guy Siddharth is working on bikes, and he uses this method to change the existing parts. So if you approach him and if you say that I want this type of part, my bike should look like so and so animal, then he'll make necessary changes into it. If you ask him that I want this hood to be changed, and I want more space over there. He makes changes and he only uses these resins and fibers, all waste fibers, waste material only he is using, and he is doing a good task. Surat. Another interesting process is spray up molding. So, labor intensive is slightly reduced. So, rather than putting up the fibers, rather than putting up, when you say hand layup, there you have flexibility of putting continuous or chopped fibers. Here you go with chopped fibers. And what you do is you spray fiber along with resin. Okay. So, suppose if I want to give a specific shape, I can have a cavity, and what I do is I just spray the resin along with chopped fibers into it, and then I allow it to dry, I allow it to cure. I may not need any extra efforts to put up larger pressure on it, and that is how it gets cured and a part can be made. So, the difference is the resin that I use is not with the brush. Here I spray it at certain pressure and it has chopped fibers with it. So, you can have a very large part at a time. Okay. So, the thing is you probably you may have made a part with hand layup technique, and you can use it as a tool for this process. Okay. So, just spray and you get the shape. I came across some papers where this is being used to generate shape memory composites. I just want to skip this now. No, you mean to say that the mold, right? You don't spray it in a certain pattern. It's not that you put them in a yeah, it acts as a pattern for you. So, pultrusion is extrusion wherein you pull the part. Okay, that is also an interesting process. Now, here the advantage is this is a mechanized process. So, you have more control over the process. You can set those parameters and you can have better control over the output. Okay. Hand layup, if you compare, or spray if you compare, you cannot claim that the thickness is so and so. It varies. Yes, layer thickness may vary, the quantity may vary. Somewhere there may be more resin, somewhere there may be less. You may have put up best efforts to remove the air entrapment, but there is always a possibility of that. But now here what happens is you are slowly moving towards mechanizing the process, and you are able to utilize many krills of fibers. So, many fibers at a time. The way these textile industries work, they have multiple threads and they combine together. So, you may always admire a shirt which has 6-7 colors into it, okay, multiple designs into it, but all those things come through multiple yarns, multiple threads, and they are put up in a specific fashion. Similarly, here also we use continuous fibers, threads are used, and they are put up in a certain way, so that they are brought together as a yarn, they are passed through the bath of resin, and then they are allowed to pass through a dye. Whatever dye you have, it takes that shape. Okay. And later on you will need to pull it. So, the way in which we carry out single screw or multi-screw extrusion, there also we need to hold it and pull it. Same way here also you need to do that. The reason being you want to maintain the dimension. The reason being that you want to maintain the whatever configuration you have set. So, for that it has to get extruded through the die at a uniform speed. So, high production rates you may get, and consistent part dimensions you may get if you are able to pull it at a certain defined, of course that from case to case it would vary, but whatever pressure you have decided, you will have to pull it at that particular condition. And the other thing is, it gives you excellent strength to weight ratio. Okay. Why? Because you are able to utilize larger fiber volume fraction into it. You can include more of fiber into these parts. It is possible to do that, and uniformly. Okay. So, certain sections that we make, it is possible to make those sections with this process. I acknowledge the videos from different sources on YouTube. Marmot. We wanted to work on this process. Surat being a textile hub, there are many people who work with this process up to this without resin. They work with only the threads. But unfortunately, I could not find out anyone who could help me with infusing resins along with this. And maybe without being into composite manufacturing, nobody was ready to support a project. So that project was not granted at two different places. By that time, we thought of some other process, and that worked. A similar process, but to make different types of parts. Here also what we want to do is, we want to use same type of yarns. We want to pull them, we want to pass them through resin, we want to pass them through it under certain predefined conditions, and then get a part. But our intention is that we want to make something which is along a center line. So we want to make either cylindrical or tubular parts. Okay. So important thing is, it's like the threads of kite. So we always wind it on. શું કહેવાય ફિરકી in English માં? We just wind it on, right? I hope you got that. I don't know what we call it on that. What do we call that spool? We don't call it spool. I am very much sure about it. But that thread that we wind, similarly you want to wind it with resin, so that later on that so-called spool can be removed and you get a tubular structure. So that is what we want to do over there. You may pass them through certain steps, and then you wind it on a rotating mandrel. Yes.
The recent submarine that included ocean gate submarine, that its body hull was made of carbon fiber which was made from
Acha, I did not know that. So I hope that was not the reason for the accident.
right application for
But I hope that was not the reason for the accident.
no, it was just not the right material.
But did they find the reason for that? Fatigue failure.
More times inside.
Hmm. Okay. Okay. So NDT also is an important aspect in composites. We did not, in next program we will include that. Okay. So so you have this mandrel, and this is the setup. You have a resin bath, and there are fibers. These fibers are passed through the resin bath, and the way, I hope you remember how that thread is wound on the so-called spool. The same way you do that. and you put it on the mandrel. Only thing is this thread, these fibers have resin with it, and then only thing that is required is curing it. Probably it is also possible to take care of the exact thickness that we want to have, the width, the thickness of this surface. So that is also possible with this process. Yes.
Curing happens while the
While and immediately after. It is maintained at certain temperature. I read that somewhere. So later on you get the part once it is cured. Post processing is carried out for proper curing. Further curing in an oven. These are really interesting things. No? It seems very interesting when you see it on videos, but probably when you start working on it, it's very difficult to create similar videos from our work. Slowly I am moving towards what I want to discuss, and the base is the resin transfer moulding. What you want to do is you want to have a closed mold, you place the fibers into it, and under pressure you pass resin through it. You allow the resin to remain along with the fiber inside the mold and get cured. Why you need to put up at certain pressure? Because you may have any complex shape inside the die, and the resin has to reach the each and every corner. It may so happen that when it is passing through this space, there are chances that air may remain entrapped because the resin may not flow the way you want it to flow. So if it is under pressure, it will definitely pass through each and every corner of it, and it will not result into any space which remains, which does not come into the contact with the resin. So to avoid that, you need to always pass this liquid resin under pressure, under a specified pressure inside a closed mold. And then you also need to see, you can go for any shape that you can think of. Of course, you have to mix certain hardeners or certain catalyst into it, and at certain temperature you need to pass through the mixing head, and then that gets into this the closed mold, and with the fabric it takes the defined shape of the mold. So here the thing is, do I have the problem into it? Oh, I have the video for this also. So once you pass it through the mold at certain high pressure, we had attempted this process in which this entire die was made up from wood. We had finished that part in the workshop itself, and we tried to use it. It worked. It gave certain shape. We also made a something like a square vessel out of it. I don't know how to fast forward thaya. So here the problem is, in this process the problem that comes is, you have passed resin at high pressure, and depending on the space available, resin would remain over there. You may always need to go for post processing, you may need to give some exact shape that you want, you may need to remove certain extra amount of material into it. The other thing is, because when you are passing the resin under pressure, in a way you are pushing it inside. So rather than that being an option, pulling becomes a better option. And so instead of RTM, vacuum infusion, vacuum resin transfer, that became a better option, because in that case, once you create this vacuum, you have to pass. So in a way, that vacuum is pulling the resin inside, and once it gets filled, you can always stop. So rather than pushing this, it is better that we go for pulling it inside.
Sir, when resin is solidified, we can change the molding period.
Yes, there is a possibility. In fact, in this case, one of the other observation that we had was the fabrics that you place inside, the fabric of the fibers that you place inside. You may have placed one over the other, but if there is even a slightest of crease into it, no, you don't have those fibers, so you may always fold. When you ask it to in transport, they get folded together. So it always has those crease. So a crease that comes over the other, it always has it becomes a porous part. Often the resin does not pass through it well, and you see that it remains there, it is solidified, but often there is air entrapped into it. So in spite of all the care that you take, those inherent problems that you face with the fabric, that remain into it. But when you are pulling out air, there is no possibility that there is air inside. Yes, yes, with this process they are being made.
One more thing, that we are pulling it. Rather than pulling, why don't we push it?
The same thing. Once the shape is a complex shape, then when you are pushing it and when the resin is passing through it, it does not have a way to always push the air out. If there is somewhere, if there is air is trapped, it remains there. Whereas when you are creating vacuum, it means there is no air inside. You have already removed air. So whatever space there is, when you are pulling this resin inside, it's not pulling, but because of vacuum, the resin easily gets into it. So it gets into it through, and so the chances of air entrapment in that the other process are reduced. Otherwise, this is capable to make any size of the part, same as the vacuum resin transfer. But the thing is, there is a chance that when you are using multiple layers of fibers, there is a chance that air may remain inside. 3D printing of parts, I'll skip discussion because we'll have a separate session for it. So I come to this vacuum assisted resin transfer, VARTM. Now this is part of my student's work, and he earned his PhD after this working on this process, and part of his results I am including in this presentation. So here, as I said, what you do is you generate the mold, but it's not necessary that you make a mold out of it. You may place different plastic bags, and you can just seal it from all sides and remove the air from it. So that easy it is. In one of the session, our team is going to create this part. So maybe you can also get involved into creating that sealing and all into it, and then try to create a part. Of course, it may not end in 60 minutes, but it's worth. So here, what we want to do is we want to seal the entire structure, place the fibers of our requirement with the required orientation or required sequence into it, and then create vacuum. And once you do that, you allow the resin to flow under the effect of vacuum, and occupy the space. So, there are three basic tasks that we need to carry out. One is initially you need to prepare the fabric and decide the proper stacking. Now, when I say proper stacking means if I wish to make them unidirectional, I will have to place the fabric accordingly. If I want to make them bidirectional, I may make a selection of the fabric accordingly to place them at perpendicular position. If I want to go for multi-directional, then I will also have to decide how to arrange them at different angles. So, those things come under fabric preparation, and then staking. I may decide that I want to put one natural and one man-made. So, that may be my staking sequence, or maybe I will put up two of carbon fibers and then 3 of glass fiber layers and then again 2 carbon fiber layers, whatever be the selection, but that staking sequence comes into it. Once this is being done, then I place them, seal the entire part and create this vacuum bag. Now, so this becomes our basic molding process. I do not need to have a prefabricated mold. If I want to have a flat part, I do not need anything. Okay, this table can be used for creating the part. I just place a plastic, then place the fibers, another plastic, seal it well, remove the air, my mold is ready. Then in this case I need to infuse the resin. So, for that I will need to decide what would be the quantity, what would be the proportion of hardener into it or other additions into this resin, so that I do not make it too viscous, or I do not make it too or I reduce its viscosity to lesser of the value. And once that is done, I infuse the resin into it, eventually I get the pure fabricated laminates. So, that is how this is being done. So, there are two major things into it. The first thing is, once you make this mold, I need to connect it with a vacuum pump. Vacuum pump, if by any chance if the resin gets into it, this altogether becomes a new scope of study. So, we do not want this resin to get into it. So, there is a resin trap. This becomes our our watchdog. So, when the resin gets into it, we stop. It means this is filled now. So, we use it that way. And on the other side, I have a resin pot. So, here the prepared resin is placed and it flows from here into this. Once it comes into this part, then I will have to seal both the ends, so that no new material comes in, no material moves out, and that is sealed and that is put up for curing. So, these are the interesting things of this part. This is easier to make, but then managing this thing simultaneously is slightly, it is not difficult, but it is slightly tricky. These are the different equipments that you need. You need a catch pot, a vacuum pump. In fact, this G clamp is a bottleneck. The way you place it, the way you use it to clamp, the way you use it to stop the flow or start the flow, that is very crucial. And in this case, the limitation is you need 2 people now, because one has to take care of this and one has to take care of the time and this part. So, unfortunately, we have only 2 hands, so we may not be able to do, but you need 2 people for that. So, we will see how this is a crucial element of it. Then various consumable materials, these are known. Maybe few more materials. So, I'll skip discussing this, because I'll again discuss this during our demonstration part. All of these steps will do, but it is how it is. See, we used different types of fabrics, and we decided the staking sequence 1 2 3 1 2 3 1 2 3, whatever be it. We cut it into a specific size, and then we placed it and we sealed the part. Once that sealing was done, vacuum was created. We decided what is our the proportion that we want to use. So, that proportion of resin pot we generated, and then we sealed everything else, and then we initiate the process. So, the same thing will do, and once this curing is done, we get a final part out of it. So, same setup, a common view, top view. Of course, I am not going to discuss the simulation part, but we found that these are for different ways in which, okay, I am not going to discuss that also, but the way in which we are, you can see here there are multiple entry ports. So, what if you are having a gate at the corner, what if you have two gates, what if you have a gate at the center, gate to enter the resin. So, they have different way of the flow of the resin. So, initially what we did was we studied through simulation, and then we decided 2-3 specific conditions of gate. So, that gating system we could reduce the number of experiments that we had to perform. To make a part, it will take 1 hour, 1.5 hours, but waiting period is 24 hours to get the part out of it. So, till 24 hours you will not be able to repeat it, because the mirror glass is only one that you have. If you have multiple, then you can make keep on fabricating multiple parts, but that is how it gets the process in that way for study also becomes slow. So, we reduced the number of gates that we wanted to study through simulation, and then we went through the exact. Probably in Modtech 22 I had a presentation, my talk was on this process. So, this is the exact thing that we are attempting. So, this is on the side, on this side, but on the center. We also investigated the shorter side and the longer side, how the flow happens, whether how the flow goes this way, how the flow goes the other way. What if there are two over here? What if there are two on the diagonal corners? So, all possible conditions we had simulated, and then we had made certain selections. So, okay, this is repetition of the. The best advantage is that you are able to reduce the number of voids. Air entrapment is largely reduced with this. Tooling cost is almost nil, because if you want to generate simple parts, you can use available parts, and you can generate and get the slope also, that is possible. Suppose if I want to make a flat part, that is fine. If I want to make a curved part, I can use any available metal piece. Suppose in the workshop you have MS plate, you can just pass it through a roller and give it certain radius, and then you can use it as the base and create that part on it. So, for simple parts, there is no requirement of molds also into this process. So, the other allied costs are less, and the other things, yes, they are known. There are very many applications, few of them I have listed out, and this is something which I have. If you search VA RTM applications, out of the top 5 videos that you see on YouTube, 4 would be related to making a boat or a yacht. Okay, because it's that simple to make. So, then there are you can make large panels. We attempted to make when our student team was taking part. Maybe in 21 we tried. 21 was COVID, right? So, in 21 we tried. So, in 21 what they did was they wanted to reduce the weight. Their requirement was something minimum requirement, and their weight was getting higher to it. So, they had no other option but to replace the aluminum panel to create the outer body of the car. So, they removed it, and they used this setup, and they created the carbon fiber panels, and they fitted it on it, and they got some extra prize also for utilizing a different strategy of making the body. So, large panels you can make, and there are many other applications almost in all the fields where you are where you need to use the man-made fibers. This is becoming a good option.
What is the
It depends upon what number of layers you decide. Say for example, as per ASTM standard, somewhere it would reflect, I don't remember exactly, but suppose if your requirement is that its thickness should be 2.4 mm, say for example. So to generate that 2.4 mm you need few number of staking, and so that never came to our mind, and in our case the cost of fabric increased because of that. So 12 was the ideal number. If you set 12 number of layers with carbon fiber or glass fiber, it will give you a dimension which is a required dimension. Say if it is 2.4, minimum to max there is a range of thickness that you, so minimum thickness you were getting with it, maybe 2 or 2.4 mm. So that would come with the number of fabrics that you use. Okay, more thickness you need, you may need to go for more number of layers of the fabric. So these are different things which we have explored. We have worked with man-made fibers, carbon fiber, glass fiber, aramide fibers. We have worked with few natural fibers also, mostly jute and flax. I remember that we have worked on a larger scale. The other were in the initial screening test we had worked, and then later on we had eliminated them. So they are still to be investigated into more details. For matrix we used epoxy resin and polyester resin. So these are different materials that we have explored till now in our lab. This was interesting when to decide. If you remember, I talked about hybrid composite in a slide. There was layer by layer. Those layers that you make, they are separate. So there is one carbon layer, there is glass layer, and carbon layer and glass layer. So as I said, we wanted to have 12 layers. Our requirement was to 12 layers. So what we did was we went for neat specimen. All carbon fiber layers, 12 layers, all glass fiber layers, all aramide layers. But then we wanted to have hybrid of all these three. So how to decide those? You can have carbon, glass, aramide, carbon, glass, aramide, carbon, glass, aramide, or 2 carbon, 2 glass, 2 aramide, 3 carbon, 3 carbon, glass, 3 aramide. But by doing all those combinations, you always need to maintain that their total should remain 12. So eventually we came up with these two strategies of hybriding them, CGA 4 times, or 2 carbon, 2 glass, 2 aramide that we did. So that is 6, and again repeated 6. Now it was interesting. See, when I repeat this, the first layer is carbon, glass and aramide, then again carbon, glass and aramide. So on one side your outer fabric is carbon, and on the other side your outer layer is aramide. So now it is up to us to decide. As I said, that when you are placing it, when you are making it, one side comes out to be very smooth surface, and the other side may require post processing on it. So do I want to have post processing on carbon side or on aramide side? That was also interesting thing. And eventually we found that on the outer side, carbon fiber is better than the aramide one. Okay, I am not going to discuss that part, but carbon on the smooth, on the better finished side came out to be a better option. Then once we fabricated, because we wanted to have different orientation, so we made a part and then we marked those different orientations. So this was 0, 90, this fabric is 0 and this fabric is 90, and then we cut it at another angle, 45. So if you see here, it is 45. If you see here, the angle that comes over here is 3060. This is 1575. So that's how we got. And then it was interesting. Himanshu had put up some. Even he worked on some simulation and came up with strategies to maximum utilization of the part. So I'm still using it as a topic in my production technology class, where I talk about strip layout. I talk about strip layout. This is not strip layout, but how to have maximum utilization of the part. So for that, how many number of maximum samples that you can get. Now see, for tensile, as per ASTM standard, there is certain length. For impact, the length is small. For flexural, strength is somewhere in between. So on a single fabric, you may go for multiple positions and get multiple parts, maximum utilization. I think they will show you one such strip wherein those parts have been cut, and you see that only minimum amount of material remains into it. So these were cut with abrasive water jet machining. Initially we did it with our own machine, but then when we approached somewhere outside, and we got another machine also for use. So this is how we, after selecting those different staking sequences, we also decided what sort of orientation we want into a standard part. So these were samples for tensile testing. We used ASTM D3039 standard, and as per that standard you need to put certain end tabs. As per the standard, either those tabs have to be made from the parent material, the fabric that we are using, or it has to be an emery paper. So we tried with the parent material because we had that with us, and there were PCs available also, wastage materials. But the problem with this is, this being very smooth, carbon fiber and glass fiber being very smooth, it could not be held in the clamping of the machine. So it would flow out of it, would just get released out of it, because of it would slip out of it. So then we had to use this emery paper so that it remained firmly into it. And as per this standard, different parts were made and tensile testing was done. Similarly, impact testing was done. Similarly, flexural testing was also done. I'll quickly go through it. I have time, right? કેટલી વાર છે જો? Still half hour I have? Okay. So when we carried out tensile testing, I hope you remember, we had 3 neat specimen: carbon, glass and aramide, and then there were combinations of it, different hybrid structures of of it. What we found was the best strength. Eventually this is something which you will notice. This comes out to be a best option, carbon, all carbon, or any one of these in different conditions. Now it is interesting to know why CGA, CGA, CGA 4 times is better in some cases, and why C twice, G twice, A twice, double, how that becomes a preferred option than the other hybrid part. There are different results. I'm not sure where I've included all of them. No, we haven't included all of them, but that is an interesting observation. And I tell you, when you are working with statistics, when you use statistical tools, you will not come across the reality. Statistics goes with numbers. So what number you give, accordingly it will give you a result, and eventually it will tell you the carbon fiber is weak. You may have made mistake in the observation. But when you are going for characterization, and when you observe the part, when you break it, when you see those parts, the way they break, that will give you the real picture. So as Professor said in the morning, that characterization is something which is very much required now in nowadays. It is because of that. Because everybody is using statistics, we feel that that becomes a shortcut to publish with numbers. But that's why it's not getting accepted easily. We need to substantiate our statistical finding with certain real observations that you see. So to compare those results, we need to combine it with either it can be surface characterization through SEM or the other processes, or maybe you go for some mechanical testing, but you need to show it. Even mechanical testing, you claim that okay, this has got very high tensile strength. Carbon all 12 have got very good tensile strength with 090 orientation. You get a similar result with one particular combination of hybrid structure also. It also gives you a similar result, though its strength is less. Please observe this. Though the strength is slightly less, the variation is quite less over here. So even though this strength is less, this is more reliable for me than this one. This is the statistics I am talking about. I am only relying on the value that I got. What I am getting is say 450 megapascal over here. What I get over here is maybe 440, 430 megapascal over here. But you see, in the number of results that you have, the variation over here is less as compared to here. This result seems to be more reliable to me than this one. But if I only talk about the best tensile strength, I will have to talk about this only as per this data that is available. But when I go through this, detailing through characterization, when I go through this detailing through characterization, or even I go with only glass fiber, this one 090 orientation, this one, in all this, all glass fibers, neat glass fibers has the minimum strength over here. Okay, that strength is even less than 100, but there the variation is even lesser than the best result, right. So the way you put up, the way you consider that result will depend upon this second part, that is characterization. So in the characterization, if I get something out of here, I can always claim that this is also very good finding, that glass fiber shows the least tensile strength under so and so condition. And why? These are the results, these are the characterization images, these are the photographs. We see that, okay, this is how the fiber behaves when it is laid at 090, and this is how the fiber behaves when it is laid at 40, 45. We believe that when you are breaking something in tensile condition, when the fibers are laid along the direction of load, it definitely has better strength, because we know fiber has better strength than the resin. So when you have 0 or 090, it naturally it will have better strength. But in some of the other finding which I will come up, we find that 45 is a better option, because that situation was that where 45, and common sense says that yes, that would be a better option. I will come to that. So merely going on the results will not give us the right picture, and that is why we need to go into details. We need to, I often quote this in my class. Do you remember there was a few years back, when maybe I was in school or maybe in college days, there was an advertisement of an oil, Saffola oil, wherein mummy was making puri, and there was a kid, puri upar se niche se gir rahi hai, then puris are moving around, and then there are those vada are just rolling, and the kid is of the same size, and he is just moving as if you are moving in the park. Just assume that you are that kid and get inside this. Put yourself in between two layers of these fibers and just see how these fibers, the way we see the stars or the other things, the same way we need to observe how these fibers are broken. So if we are able to see it through microscope, then that gives us a better picture why this has this strength with little reliability, and why this has lesser strength with maybe better reliability. Okay. So it's not that only this value, but this also plays, it also gives certain observations out of it. See, these are different observations that we have. All are 090 condition. Our orientation is 090. These are three conditions. One was this one is the aramide one, the other one was is glass one, and this is a hybrid one. All of them. Now see their breaking. How does it break? All of them together. We always claim that united we stand, divided we fall. They are united, but they have broken faster. See here, if you see, these fibers have got elongated. Why? Because they are all one, they are same material. They maintain their own basic capability, their own basic nature. Here when they combine together, they forget their own nature, they have to behave with others. So here when you observe, they break instantaneously. They may break at a higher strength, but they break instantaneously. Here before breaking, what happens is they try to get elongated, they try to prevent that breakage. Similarly, you see the same thing here also. You see this part. Okay. You get more of fiber pull out here as compared to the other case. Okay. So when I only talk about strength, probably I do not know what I conclude. I only go with the numbers. But when I observe them, maybe I can substantiate those results well, those values well, if I compare them with these observations. This is an interesting paper, it's in our journal. So in many cases, at different other angles, probably this is carbon fiber, because carbon fiber exhibited the better strength. So, we went through all these observations and we saw how in all the cases there was fiber pull out. So, the fiber remained intact, it did not break. At the most what it happened was it got elongated and later on it got pulled out from the structure. It did not break, it got pulled out of it. So, that probably exhibited in all the case, all these orientations you see, that is how it exhibited, and that probably that is the reason that carbon fiber did not break well easily. So, it exhibited better strength.
You can differentiate between pull out and breaking in the microscope, under the microscope.
No. These images are not under SEM. These are under simple microscope. In case if you are able to go in SEM or even the smaller version, it gives you the right picture. But here our magnification is only 40x. Yes, this microscope. Yeah. Yes, but here because it is only 40x, so you will the area that you will have to see would be more. You will be able to see more area, but you will be restricted by the depth of observation. You observe at different layers. See, these are those yarns, the yarns which I talked about. All threads are together. They get separated. Okay, before breaking they get separated. So here probably this is 30-60, and when you are trying to break it in a one particular, I suppose that this was elongated this way. So rather than breaking, they started getting separated. So this shows a good result. If you remember the graph, this particular hybrid combination was giving you a better strength. Why? Because it had a better opportunity to resist that breaking. It could get fragmented some other way. It could allow pull out of the fibers rather than directly breaking. So that orientations probably play a role into it. So this is the same results put up in a different perspective. That was in the perspective of those staking. Now the same results are in the perspective of orientation. So I'll again, if you see here, 0-90 orientation under carbon fiber, right? Same result. All carbons 0-90, the same result. So I'll just, they are just put up, they are clubbed together in terms of fiber orientation. Then same samples, similar samples were made using D7264 for flexural testing, and in that case again the same combinations, neat carbon, neat glass, neat aramide, and those two different hybrid combinations, and 3-point bending was attempted on these samples that were fabricated. Same strategy of fabricating, making a larger plate and then again cutting it at certain orientations to get those defined orientations out of it. So that was the same way. Here also effect of stacking sequence, if you see. Now here the thing is, when you talk about flexural strength, these hybrid structures are getting better results. What you want to do is, you want to bend them, right? Under flexure you try to bend them. So the bending of single neat carbon fiber as compared to the two hybrid structures, this would give you a lesser strength. Okay, these are almost similar, but I know that this is slightly less than this one. And the other fabric, I said that these two will compete with each other. In tensile this was giving good result somewhere. Here the other one is in flexure, the other one is giving result somewhere. Now what might be the reason? You have 2 carbon, 2 glass, 2 aramide, 2 carbon, 2 glass, 2 aramide. We came up with some observation. Yes, this is what we want to do is we want to bend them. Under flexural study what we do is we try to bend them. Yes. Now the thing is, when I consider this particular structure, suppose here I have carbon, then glass and aramide, carbon, glass and aramide, carbon, glass, aramide, and I place this sample this way, it means I want to bend it this way. If I place it the other way, aramide, glass, carbon, aramide, glass, carbon. If I try to bend it, the aramide bends lesser than the carbon on the other side, right. So, this particular situation in both the cases gave different results, and we considered the one wherein carbon was on the better side, the finished side. It means when we made it, we placed the carbon first because the bottom surface gave better finish. So, carbon, then glass and aramide, carbon, glass and aramide, that is how these are placed, this particular case, and we used it to bend. Okay. The other case gave slightly different results. Results were similar, but there was slightly different, but this was found the better one, so we have reported it. Now, the thing is, again if you see in hybrid case, this particular case, in irrespective of this, in all cases glass fibers have exhibited lesser strength. Tomorrow when I will discuss 3D printing, I will say glass fiber is giving the better results in under 3D printing with nylon. So, आज की बात आज, कल की बात कल. But today I say that glass fiber is giving lesser strength in spite of in all the combinations. So, in this particular case, two carbon layers, the carbon layers were positioned on the outermost side. When we went for bending, the carbon was at the outermost side, then carbon, glass, aramide, and then again two carbon layers came. They remained at the center, right. If you see the stacking sequence, how is it? C2, A2, can I write on this or not? C2, G2, A2, C2, G2, A2. So, these two carbon layers were, when I did this bending, they remained at the outermost side, right. This is how it is bending. So, this bends inside, this is the outermost side, and there were two carbon layers which were at the center. So, ideally when you see this bending, the lowermost part will come under tension, right, it will get elongated more. So, because it was carbon, probably it resisted more. Had we put it the other way, aramide at the outer side, probably it might have slightly given different results, because the carbon would have come at the top and it would have required to get lesser elongated when you are going under the flexure test. Am I followed? So, in that case, probably this result would have, instead of placing it this way, if I had placed it the other way with aramide at the outermost position, then this result might have been different. So, when we are carrying out this, when we are bending these parts, what we observe is there is delamination observed almost everywhere. So, what is delamination in this particular case? We have different layers of fabric, and those fabrics are in the resin. So, the resin that remains between two specific layers of fabric gets separated, that is delamination. So, I observe two separate layers, right. I see these layers are separated, right? This layer is separated, you see this layer is separated, you see this layer is separated, and this delamination you observe more between the glass fibers. Individually if you see the glass fibers, they would easily get delaminated, their strength would be very less in that case, and naturally that is the result is also similar to that. Now, this is a situation where we have placed the fiber orientation in 090. What is 090? If this is the part for flexural testing, the fibers are laid along this part and at 90 degree. This is that situation. What does that mean? There are two things. Suppose if they were unidirectional, only in 0 degree, it means some of the layers would have to get elongated more at the bottom, upper layers would have to elongate less, but at some point of time before they break, they will have to get elongated. The other option is 90 degree. So, in this case what happens is, these parts when they try to get elongated, there is delamination between them, they would get separated, and eventually because of that separation, resin layer, the matrix would break rather than the fiber, if they were only unidirectional 90 degree. But here because you have both of them, there is delamination also is observed, and the other way there is a bit of extension also happening. So, probably that is how they show better results in 090 as compared to the other inclinations. When there is other inclinations, they do not have an option, they always get delaminated, and you may also observe that they may start breaking at in case of 45 degree. I think I have that graph, that observation also, depending on fiber orientation. See, 45 gives you the minimum results, because they are placed in one particular way, this way. So when you bring them under this effect, they get very easily, both the layers would very easily get delaminated. If it is 0-90, only 90 gets delamination, 0 may not get it, delamination. But when they are at 45, both of them behave in the same way, plus 45, minus 45, they behave in the similar fashion. So there would be more of the delamination resulting into the breakage at a faster rate. So there you see at 45, the strength as compared to 0-90 is quite less. Okay. Glass fiber always remains at the lesser side, the second one, glass fiber. See, this is how the delamination goes. This is at 100x. Okay. So matrix, the matrix breaks, right? The resin would there is breaking, there is cracking in the matrix, and then the second part is the delamination of the fibers. The impact testing. This is also an interesting aspect. Here 45 says that I am the best. So again we used a standard and made similar parts, C12. I suppose those numbers might have changed. The staking is same. What you observe is that when in most of the case, because you had a part that has to be brought under the impact. So naturally, if the fibers were able to break, then this should have separated. But depending on the orientation that you had inside, this breaking was at the same load, the breaking was different in different conditions. See, these are different orientations, 0-90, 45. So this would show that here this had lesser resistance to impact. Okay, when I say impact energy, I mean to say that here the resistance to impact is less. Here the resistance to impact is more. So it got lesser of the effect on its breakage. Why so? In case of 0-90, what happens is, again, this is how it is. So when this has to break, and if this is how it is, these two will remain together, this will remain separate, and this will want. How do I show it? These are all at one particular angle. They will easily break this way. This will remain one group, the other will remain another group. If this is how it is, all of them would break. They may or may not break, but this is how it behaves. But this will easily separate out. When it is 45 plus 45 minus 45, they take time to decide, मैं गिरूँ या तू गिरे. They will take time who would break first. So in that, the amount of energy that it absorbs would be more. So it will not break that easily. It may come under the effect, but it will not break the way 0-90 or the nearby inclinations would break. Okay. So in impact 45, yes. Yes. Permeability was a different study, and I haven't included over here. But yes, in fact, the way you are flowing, deciding the flow of the resin, it will also have its effect. Permeability would change when you fill the resin from the center and allow it to percolate along the radius, or you allow it to come through a diagonal corner and then you allow it to flow. It will take a radial path, it will make a radius, it will keep on growing that radius and flow, and eventually it would reach the other corner, get into that pot, and there would be some corners which are left without resin. So if you are making part from that particular corner, you may leave that part where there is no resin, but nearby also resin infusion is less. So they would become lesser, they would exhibit lesser strength. The way, suppose if you are flowing through entire shorter length or longer length, it will more or less it will flow together throughout. So in all the cases, because of the number of fabrics, the permeability it was displacing was different. Maybe I wanted to keep it short, so I did not include that part, but that is also an interesting study. Himanshu has 2 papers on permeability. I would request you to download and increase my number of downloads. I'll try. I'll try to reply for. Yes. 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 Probably I think there is no major technical reason behind it. It is, see, that is a wastage material. You can source it anyhow. For a BTech project, we have used the waste textile. See, when you stitch a cloth, there are certain end parts of the cloth which remain useless, chote parts. We have also flowed the resin, passed that resin through that also, and it is also showing good strength, cotton part. So when you don't need to put it in a particular orientation, arranging everyone by time, placing these chairs perfectly in the room takes time and energy. If you are to dump chairs into it, you don't need major time and effort into it, right? So similarly, I believe that random orientation would become more prominent in case of natural fibers. If you want to align cotton fibers, you will need much more effort, but you use natural cotton only, you use natural jute only, then it does not orient itself correctly. You need to have separate fabric for it. I don't see any specific reason why people do that, but probably it is easily available. Properly aligned parts will give you better strength always. Yeah, so for functional parts, no, we should not use random orientation. But for prototyping or creating artistic parts, suppose you want to lay a glass on this table. Instead of glass, create a plate with transparent resin and put anything into it, maybe your and my photograph. Right? So instead of glass, you can place it. It will not break the way a glass can crack. So there, such random things, no, they seem abstract and they always fascinate you. So for prototyping or for creating artistic part, that is fine. But functional parts, I fear, no, random orientation may not help. Oh, that was the last. So I believe that vacuum assisted resin transfer molding process will is a good option to work on, because you don't need expensive setups like the process like pulverization or maybe a process like that winding process. If you want to go for RTM, flowing the resin under pressure, then you need a proper die, you need to maintain proper pressure, you need to prepare a die as per the shape that you require. This can be an open die. In case of vacuum infusion, it can be an open die also. If it is closed, that is also better, but otherwise it can remain open. You can give a specific shape, you can flow the resin into it and create a part. So as far as the complexity of the system is concerned, as far as the the ease of carrying out the process is concerned, VITM comes out as a better option. And the other thing is, under given situation, bearing certain basic conditions, you can work for a smallest size of part to a large, very large part also. So the range of parts that you can work on with this, of course, the way you will have to put up those vacuum pumps, the way you will have to decide the way of infusion, everything would change. It would become complex. Sometimes it may happen that the infusion from multiple places may create a different sort of quality of part at different positions. But it is possible to start working from the smallest maybe to the largest part. So that is an advantage with this process. I think I end my session here. Yes, and there is a study. I recently referred one review paper wherein what they did was they infused the resin in this process by mixing nanoparticles into it. Now, when you infuse something, those particles may get entrapped in the fiber and may also restrict the easy movement of the resin. So, the way it would behave, whether it restricts the flow, whether it concentrates the powder at one particular position or allows it to flow, and under those different situations how that part would behave, that is something which is an interesting study. So, yes, but then to create that colloidal solution altogether is a different issue. We may have to decide whether we want to go for sonification or we need to go for some other ways of doing it, and then trying to maintain that even dispersion of the particles into that resin, that also is an issue. So that is something interesting which is coming up recently, maybe in 2023 only there is one review paper that has come up on that part, and there is a scope to work into that area. So yes, and combining natural and man-made fibers, how we can utilize more of the natural fibers and reduce the man-made fibers, and then somehow contribute towards the carbon footprint, that is also something which is interesting. So yes, this seems to be an interesting process to work on, though in present days when we are more fascinated with automation and more fascinated with processes like 3D printing, this also has still got a scope to work on and maybe create some better ways of making functional parts out of it. So with this I come to the end right now. I am open for discussion. This process will try to carry out tomorrow in our lab session. This would be one of the laboratory assignment tomorrow. Okay, so any questions? Yes. Yes. In the screening level, we went through different conditions, but then we wanted to restrict the number of experiments. One limitation was number of layers were fixed at 12, because we wanted to have a specific thickness. Now, when you have 12 and when you have 3 number of fabrics, so when you need to have 3 fabrics, your combinations get restricted. Either you can have when the number is 12 and 3, so maximum number of one fabric that you can put together is 4, 4, 4 and 4, or 2, 2, 2 and 2, 2, 2, or 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That is how you can put up. So if I would have gone for the third also, then we could have required the number of experiments would again increase. So we restricted. We made the study on the only single fibers, only carbon, only glass, only enamide, and then we came up with 4, 2, 2, 2 and 2, 2, 2. This is how we came up, and then later on we took 4, 4, 4. We could not go for 8, 8, 8. So that's how we restricted ourselves.
What if we go for symmetrical layer? Half of the layers are symmetrical to another half. So both the sides will have carbon.
That is also a possibility, but to arrange them, when you want to arrange them, say carbon, glass, aramide aramide glass carbon. This is how you may have to arrange. Yeah, that is also an option, but we did not go for it. Yeah, we did not go for it. Maybe in our screening test it did not came out as a better option probably. That's why. Yes, more combinations are possible. Suppose instead of 3, if we had gone for 2, only 2, then the number of combinations which you could have created would have increased. Okay. So even in fact this is also a good way of explaining LCM and HCF to our kids.
So in this we have taken 3 materials, glass, carbon and carbon. And in that we have made 2 layers, one material, second material. Suppose that you make 2 different composites, one is from carbon and one is from glass. And you put one material on the other and you test it. Then again it will show the same result like this or that.
I did not get. You are saying that say 6 layers of carbon fiber and 6 layers of glass fiber together, right?
Yeah, I just want to say that you are mixing 2 materials, carbon and the glass. And you are finding that one kind of material fails at some point.
Yes.
जब binding करते हैं तो एक carbon
Yes.
बच जाता है वो
Yes.
अगर मान लीजिए हम 2 अलग-अलग material carbon सारा कंपनी बनाते हैं और glass कलर बनाते हैं फिर टेस्ट करते हैं क्या कभी ऐसी कोई
No, but in that case carbon 12 layers of carbon was a single material. 12 layers of glass was a single material, and then third was say carbon and glass in different ways. That is how it goes. So there were 3 neat materials and then combination of those 3 in specific ways. So just now as I said, if instead of 3 if we had 2, then we could have gone for more number of combinations. If there were only 2 materials, we could have taken 6 6, then 4 4 4, 3 3 3, 2 2 2. That's also, so number of combinations would have increased if there were only 2 fabrics. But because there were 3 fabrics, so that was restricted. And yes, then those combinations also can be altered. But we have restricted our study to these 5 combinations, 3 neat and 2. There are further studies which are related to natural fiber, but I haven't included them over here. Those results are also out, and wherein we have used jute and flax as along with glass fiber. So those results are also there, but I haven't included them here. Carbon, yes. Naturally, jute has lesser strength as a fiber, and when you are going for certain volume fraction with any fiber and resin has a lesser contribution in the strength as compared to fiber. So because carbon fiber is there and it has the better best possible strength as an individual entity, so naturally carbon fiber gave better strength, because considering that those resins were same, considering that volume fractions were same, then in that situation carbon fiber gave better results as compared to the jute one. Any natural fiber you take, man-made fiber will give you better strength.
And is there any matter of absorptivity of the material?
Yes, especially in case of natural fibers, that has an effect, that absorbs the resin also. So when especially when you are studying the flow is restricted in case of natural fibers, because the fiber itself first wants to absorb the resin rather than allowing it to flow. So in a way it restricts the flow. So the flow time study that we have, natural fibers take more time for completing the entire same size of same volume of the material as compared to the natural fibers.
So that affects the strength also?
I am not sure about that.
Then the delamination may be delayed.
Yes.
Because the fiber is taking up the resin in a better way.
Yes.
So delamination may be delayed.
Maybe it has a better cohesion with the resin, but I haven't seen that in that way. Maybe I'll have to go through the results.
It may lengthen the process
Yes.
of breaking the composite.
But yes,
but
it may.
strength of the composite
No, but that way I think the man-made fibers give better strength as compared to natural fibers.
maybe not strength, delamination. But
Yeah, but I'm not sure because I haven't gone through that. We did not go through that, I suppose. I'll go through the results and get back to you. Of course, those reports are there, and we can always discuss in the lab. Yes. Anything else? Okay. So we stop here for today. for this session. We will take a very quick break, and once we are freshen up in next 5 to 10 minutes, we will be back with the next session with Professor Dumitru. Okay, so 10 minutes of break.